Video will be the go-through video for the 2018 O-level pure physics practical paper. So I'm going to focus on section B. So by now you should have received the marked copy of your practical report. I'm going to focus on section B. So I am going to skip all the part A, part B, the table and the graph, because we have done that in class. So I'm going to focus on G, H, and H part 2. Okay, so before I go into part G, which is basically whether the gradient should agree, let's talk about how the question is being asked. Okay, do not copy the answer first. You can always pause it to copy later. So what happened is that first you would notice that for this question, you are only required to state whether you agree with the suggestion or not. If you look at the word state, it only means that whether you, yes, I agree, or no, I disagree. That's all they ask for. And then in the second part, they also didn't ask you to explain your decision. They are basically asking you to justify your answer with your result. So if your GA result and your GB result, they are not of the same value, they are very far off, then that is a justification on you not agreeing to the statement that is highlighted in blue here. If you decided that you agree with the statement and your results for GA and GB in here, your GA and GB really does agree, then yeah, then that's it. That is the justification. You are not required to actually go through the explanation from a theory point of view, like how V equals to IR and all that workout. No need. They just require you to pick up the correct data to support your answer. Okay, now in practical, it is very rare that you can find exactly the same value. Okay, meaning that even if you look at here, even for my data, GA and GB, they are actually different. One is 0.012, one is 0.013. Mathematically, they are not the same value, but in practical, we accept to some degree of margin of error. So if it is just a difference of 0.1 or 0.001 in this case, we can say that they are actually the same. Okay, but down here you have to justify. So what do they mean by justify? So you have to code your data first, okay, and then you may want to do some measure of how different they are. So in my case, I decided to use percentage difference to justify. So I'm just saying that, okay, I'm aware that there is random error in my experiment, so I think a difference of 7.7% is reasonable, and that is fine. Okay, so as long as in this question you show that you know that you should refer to your GA and GB value, that is half a mark, and then you try to do some justification about it. Maybe you can even do GA minus GB and say that, okay, the difference is very small, it could be due to random error. It is fine as well. Okay, so that's justification. Now since this is a go-through video, I feel that maybe we should examine on how on whether or not, if I do a mathematical proof, will GA and GB be agreeing to one another. Okay, so let's do this. So let's go back to our diagram. You are basically given a resistant wire, but the tricky thing is that now you have this unknown length that is. Okay, so if you look at the rest of the circuit, basically this voltmeter is measuring the potential difference across different section of the wire. So I'm going to simplify this circuit into this. So basically this yellow part, the coil of wire over here, I am going to represent it separately with this unknown resistor. and the first half of the ruler will be represented by this green box, which is this section, and then after that the second section will be represented by this box. Okay, and I'm just going to try some math. Let's say I do not know about this, and I imagine myself putting the voltmeter over here. Now if I put the jockey at right here, or in this case down here, I am just registering the part of the PD across just the first part of the wire, and the reading, which is my voltmeter reading, I will just use symbols so that it is not so confusing, will be equals to I'm given, I think if I remember correctly, a 3-volt battery. So meaning that this potential difference that I'm measuring will be taking the whole 3 volt divided by my total resistance of the green resistance plus the coil plus the blue, meaning that I'm just getting this entire thing, because that's my effective resistance, the total resistance that my 3-volt battery is going to distribute its voltage to. And obviously down here what I will have is that I would measure a length of X. So let's say down here I'm measuring a length of X, so I will write X over here. And we know that the resistance is given by a constant multiplied by X, because they are directly proportional. So I will just take like that, Kx, where K is that resistivity or constant that we are talking about, right? So the voltmeter reading is actually given by this parameter here. So I will get this particular equation. And because in our experiment, I am going to plot X against V against X. So because of that, if I am going to plot V against X, so if now I have a graph of V against X, it means that a straight line on such a graph will have an equation that looks like this, whereby my M is my gradient. So in this case, if I compare this equation, the green one, with this blue equation, then I would know that my gradient is actually the coefficient of X, which in this case will be 3x over R total. Agree? Yeah, so okay, that would be one part of my argument. So now what I'm going to do is that I'm going to put my jockey all the way over here, the max out part. So if I do the max out part, imagine in actual thing I put it over here, and I am measuring X from here to here, meaning that I would not be able to detect this and whatever remaining extra part that is here. But what if I could imagine that I mentally or mathematically I make this and this so close that it goes like that. So meaning that I only don't know this length, but I'm able to do this entire length, right? So if I were to do that, then I would have an unknown length of wire that I can call L, that is coiled around this wooden stick. So in that case, my equation for my voltmeter, if I put my jockey all the way to the back, would be the voltmeter reading will be equals to my total EMF divided by the total resistance, and then since I am measuring the entire thing, it will be made up of Kx, because now my X would be this entire thing, right? Correct? Plus K of L. correct? Because I do not know this L. This L that refers to the length of the wire around the wooden stick, I won't know, right? So let's rearrange this. I will get V equals to 3kx over out T plus 3kl over out T. And I can rearrange this so that it looks more comfortable like this, plus 3kl over T. And I'm going to plot V and X on a Vx graph again. So meaning that I will form another line, and this line will still take the form of V equals to mx plus c, and it checks out because L, which is the length of the wire hidden in the coil, is fixed. K is a constant that we defined at the beginning, which is the resistivity of the material of the wire. And then we have 3 is the 3 volt, the battery's voltage, which is also fixed. Total resistance, we didn't change. So this entire term over here is a constant, which agrees with this. And again, we can see that the coefficient of X is given by the gradient, which is equals to 3k over RT. So from this mathematical proof, you can see that in line A, the gradient would be the same as the gradient of line B. Okay, so that's the that is the mathematic behind whether GA and GB should be the same, and they should be the same. Yeah, of course, you would not be expected to perform such calculation on the spot of the examination. Okay, but that is, I mean not but, that is why they didn't require you to explain using theoretical knowledge, but rather to just use your answer to justify. Yep. And this 2 mark is also a reward for those of you who can perform electricity experiment to a good accuracy, because if you do it properly, you can see that actually the 2 lines are very parallel to one another. Okay. Okay, then next thing is about H part 2. H part 2, if you look at the phrasing of the question, it is actually very similar to your source of error question. So basically they are just, you know, giving you a fanciful context, but they just want you to state the sources of error. So the basic component of the source of error remains. There are many of them. You can say that it is not straightened and therefore not parallel to the scale of the ruler, and because of that the X reading will not be accurate, and hence it will be good if you can relate the X to sorry, I didn't point properly, because your X reading will then affect your G reading, which will then affect the L reading. That will be a wonderful answer. Okay, then the other thing you can talk about is the jockey force, the force exerted onto the jockey. But if you are talking about that, then please talk about the effect it has on the cross section, and then the effect it has on the resistance of the wire, and finally to V. And of course, once your V is affected, then you can point it back to the gradient G, and hence the final result of L. Okay, if you have other questions regarding precision rule and things like that, please have a separate appointment with me so that I can go through with you. Okay, bye bye.